Hello, in this lecture we will find the area of triangle ABC in two different ways. In the drawing we have triangle ABC with side AB that equals to 8 units, side AC of triangle ABC equals to 14 units, and angle ABC equals to 2x in its size, 2x degrees in size, and angle ACB of triangle ABC equals to x degrees in size. And we want to find out the area of this triangle, triangle ABC. So first of all, we will do a construction from point A. We will draw segment line AD in such a way that the angle that will be created equals to 2x. Okay, so we will draw from point A line segment AD, that is to say the touching point between the line segment to side BC of triangle ABC is defined as D. So according to our construction, angle ADB will be equal to 2x. Okay, so we made a construction of line segment AD in such a way that angle ADB equals to 2x degrees in size, exactly like angle ABD that also equals to 2x degrees in its size. So actually in triangle ABD, this triangle, we have two angles that are equal to each other. In triangle ABD, angle ADB equals to angle ABD, and both those two angles are equal to 2x degrees in size. Okay, again in triangle ABD, angle ADB equals to angle ABD. Those two angles are equal to 2x degrees in size, and we actually have a rule. I will call it rule number 1. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So I will read rule number 1 again. Rule number 1 states that in front of equal angles in the triangle there are equal sides. So actually, if we have triangle ABC that has two equal angles, in this triangle ABC, we know that it has two equal angles, that is to say angle ABC equals to angle ACB. Those two angles are both equal to angle alpha. So according to rule number 1, in front of equal angles there are equal sides. So in front of this angle alpha we have side AC, and in front of this angle alpha we have side AB. And according to rule number 1, in front of equal angles there are equal sides. So the sides that are in front of those equal angles, that are AB and AC, are also equal between them. That is to say AB equals to AC. According to rule number 1, side AB of triangle ABC equals to side AC. Again, in this triangle ABC, we have two equal angles. Those two angles are equal to each other. Both of them are equal to alpha. So according to rule number 1, in front of equal angles there are equal sides. So in front of those two angles we have side AB and side AC. And according to rule number 1, those sides are also equal to each other. That is to say AB equals to AC. Okay, AB equals to AC. So we actually can implement rule number 1 in our triangle ABD. In triangle ABD, we have two angles that are equal to each other. Angle ADB equals to angle ABD, and both those two angles are equal to 2x in size, 2x degrees in size. Okay, so in triangle ABD, angle ADB equals to angle ADB equals to angle ABD, angle ADB equals to angle ABD. Those two angles both are equal to 2x degrees in size. Those two angles are both equal to 2x degrees in size. Therefore, according to rule number 1, in front of equal angles there are equal sides. So in front of this angle 2x, we have side AB of triangle ABD, and in front of this angle 2x, we have side AD. So according to rule number 1, those two sides that are located in front of equal angles are also equal between them. That is to say AB equals to AD. According to rule number 1, AB equals to AD. According to rule number 1. Because of the fact that in front of equal angles there are equal sides. Those two sides, AB and AD, are located in front of equal angles. Therefore, they are also equal to each other. That is to say, AB equals to AD. Okay, AB equals to AD, but we know that AB equals to 8 units. It is given us that AB equals to 8 units in size. AB equals to 8 units in size. Okay, AB equals to 8 units in size. So from this equality we can deduce that we can derive that AD also equals to 8 units. AD equals to 8 units. AD equals to 8 units. Okay, AD equals to 8 units. So this side AD of triangle ABD equals to 8 units in size. And we also have rule number 2. Before I will present to you rule number 2, I will explain what is exterior angle and what are interior angles. So actually, if we have triangle ABC, that can be any triangle, not necessarily our triangle ABC, but any other triangle. So this triangle ABC has three interior angles: angle alpha, angle beta, and angle gamma are defined as interior angles. They are interior angles because they are located inside the triangle ABC. They are defined as interior angles. Those two, and also this angle is defined as interior angles, while angle ABL, this angle is defined as exterior angle. Exterior angle because it is actually located outside triangle ABC, therefore it is defined as exterior angle. So actually those two angles are located in the opposite direction in relation to angle gamma. Those two angles alpha and beta are located in the opposite sides of angle gamma, therefore they are also defined as opposite interior angles. In relation to angle gamma, they are defined as opposite interior angles because they are located in the opposite side of angle gamma. So those two angles alpha and beta are defined as opposite interior angles. Okay, those two angles alpha and beta are defined as opposite interior angles, and this angle ABL is defined as exterior angle. So now I will present to you rule number 2. Rule number 2 states that the exterior angle of a triangle that in our example is angle ABL is equal to the sum of the two opposite interior angles. So I will read rule number 2 again. Rule number 2 states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So actually this exterior angle ABL, equals to the sum of the two opposite interior angles. The two opposite interior angles are alpha plus beta. So angle ABL equals to alpha plus beta according to rule number 2. Again, according to rule number 2, the exterior angle, angle ABL, this angle is equal to the sum of the two opposite interior angles, that is to say it is equal to alpha plus beta. Okay, angle ABL equals to angle alpha plus angle beta, according to rule number 2. Okay, again, the exterior angle, angle ABL, equals to the sum of the two opposite interior angles, that is to say angle ABL equals to alpha plus beta. Angle ABL equals to alpha plus beta. And again, we can implement rule number 2 in our circle, in our drawing. Okay, we will implement rule number 2 in our drawing. We have triangle ADC. In triangle ADC, those two angles are defined as opposite interior angles. So angle DAB, this angle DAB, and angle ACD are defined as opposite interior angles. Those two angles are defined as opposite interior angles in triangle ADC. And angle ADB, this angle, angle ADB that equals to 2x, is defined as exterior angle. It is exterior angle of triangle ADC. Okay? Exterior angle of triangle ADC. Okay, angles DAB and angle ACD are defined as opposite interior angles. Those two angles are defined as opposite interior angles in triangle ADC, while angle ADB that equals to 2x is defined as exterior angle of triangle ADC. This angle, angle ADB that equals to 2x, is defined as exterior angle of triangle ADC. So according to rule number 2, the exterior angle, this angle that equals to 2x, is also equals to the sum of the two opposite interior angles. That is to say, it equals to angle DAC plus angle ACD. This angle ACD. This is according to rule number 2. Again, according to rule number 2, the exterior angle that equals to 2x, this angle, is equal to the sum of the two opposite interior angles. That is to say, it equals to angle DAC plus angle ACD. Again, according to rule number 2, the exterior angle that equals to 2x is equal to the sum of the two opposite interior angles that are angles DAC plus angle ACD. This angle, the exterior angle that equals to 2x, equals to the sum of the two opposite interior angles. Angle 2x equals to angle DAC plus angle ACD that are defined as the opposite interior angles. Okay? But we know that angle ACD equals to x. So angle ACD equals to x, so we can substitute angle ACD by x. So we will get that 2x equals to angle DAC plus angle x. Okay, we have the identity that states that 2x equals to angle DAC plus x. So here we can substitute x from this equality, and we will get that 2x minus x is x, equals to DAC plus x minus x is DAC. So x equals to angle DAC. So we got that angle DAC equals to x. Angle DAC equals to x, that is to say angle DAC, this angle equals to x degrees in size, angle DAC equals to x degrees in size. So actually in triangle ADC, this triangle there is two angles that are equal to each other. Angle DAC this angle is equal to angle ACD, and both those two angles are equal to x. Okay, in triangle ADC, angle DAC equals to angle ACD, those two angles are equal to x degrees in size. So according to rule number 2, in front of equal angles, they are equal sides. So in front of this angle, we have side AD of triangle ADC, and in front of this angle, we have side DC of triangle ADC. So according to rule number 1, those two sides are equal to each other. That is to say, AD equals to DC. AD equals to DC according to rule number 2. Okay, according to rule number 2, side AD of triangle ADC equals to side DC of triangle ADC. Okay, AD equals to DC. But we know that AD equals to 8 units in size. AD, we have already found out that AD equals to 8 units in size. So according from this equality, we can derive that DC also equals to 8 units in size. DC equals to 8 units in its size. DC equals to 8 units in size. Okay, so in the next step I will present you a new rule number 3. But before I present to you rule number 3, I will explain what is the base of an isosceles triangle. Actually, if we have an isosceles triangle, triangle ABC is an isosceles triangle. That is to say, AB equals to AC. In triangle ABC, that is an isosceles triangle, AB equals to AC. For that reason, it is an isosceles triangle, because it has two sides that are equal to each other. AB equals to AC. So side BC of triangle ABC, side BC of triangle ABC is defined as the base of triangle, the isosceles triangle, triangle ABC. So I write it down. Side BC of triangle ABC is the base of the isosceles triangle, triangle ABC. Again, side BC of the isosceles triangle, triangle ABC is defined as the base of triangle ABC. So now I present to you rule number 3. Rule number 3 states that the height to the base in an isosceles triangle divides the base into two equal parts. So I will read rule number 3 again. Rule number 3 states that the height to the base in an isosceles triangle divides the base into two equal parts. So actually, if we look at triangle ABC that is an isosceles triangle, if from point A we will draw height to the base BC, if from point A we will draw height to the base BC, you should remember that the height always gets 90 degrees with the base. So actually this angle equals to 90 degrees and this angle is also equals to 90 degrees. So the height, the red line is the height to the base, the height to the base BC divides the base BC to two equal parts. So we will define the touching point between the height to the base BC. We will define the touching point between the height and the base as point D. Point D is the touching point between the height and the base BC. So the height to the base, the height AD to the base BC divides the base BC to two equal parts. That is to say BD equals to DC. Okay, BD equals to DC according to rule number 3, because the height AD divides the base BC to two equal parts, that is to say BD equals to DC. Okay? BD equals to DC. BD equals to DC. So we actually can implement rule number 3 in our triangle ABD, that is actually an isosceles triangle. Triangle ABD is an isosceles triangle because AB equals to AD, side AB of triangle ABD equals to side AD. Okay, therefore triangle ABD is an isosceles triangle because side AB equals to side AD. So if we draw from point A height to the base BD, okay, first of all we will define the touching point between the height to the base BD as point E, and the height always creates 90 degrees with the base, so this angle is 90 degrees and this angle is also equals to 90 degrees, and we will define line segment AE as E as H, that is abbreviation for height. So AE equals to H, that is abbreviation for height. So this height to the base BD divides the base BD to two equal parts, that is to say BE equals to ED. Okay, BE equals to ED. Okay, so according to rule number 3, in triangle, the isosceles triangle ABD, BE equals to ED, according to rule number 3, because the height divides the base BD to two equal parts, that is to say BE equals to ED. If we define BE as A, if BE equals to A, according to our definition, if BE equals to A, then from this equality we can derive that ED also equals to A, ED also equals to A, okay, ED also equals to A. Okay, so in the next step we will focus on triangle ABE. So actually the green triangle ABE is an a right triangle because angle AEB, this angle equals to 90 degrees. So I write it down in the green triangle, triangle AEB or ABE. Triangle ABE is a right triangle because angle AEB equals to 90 degrees. Okay, so triangle ABE is a right triangle because angle AEB equals to 90 degrees. So we actually can implement the Pythagorean theorem on the right green triangle, triangle ABE. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse in triangle ABE is AB. So AB squared, the square of the hypotenuse is AB squared, equals to the sum of the squares of the perpendiculars equals to BE squared plus AE squared. Again, in the right triangle, triangle ABE, according to the Pythagorean theorem, the square of the hypotenuse, that is AB squared equals to the sum of the squares of the perpendiculars equals to BE squared plus AE squared plus AE squared. Again, AB squared equals to BE squared plus AE squared, according to the Pythagorean theorem. Okay, but what is the value of AB? AB equals to 8 units. It is given us in the question. So AB square is 64, because it is 8 square equals to 64. BE equals to A according to our definition. So BE square is A square plus AE square. AE equals to H, so AE square is H square. So we got that 64 equals to A square plus H square. Here we will subtract A square from this equality and we will get that H square equals to 64 minus A square. So we got equation number 1 that states that H square equals to 64 minus A square. Okay, H square equals to 64 minus A square. In the next step, we will focus on triangle AEC. Actually, triangle AEC the orange triangle AEC the orange triangle AEC is a right triangle because of the fact that angle AEC equals to 90 degrees. This angle equals to 90 degrees. Okay, triangle AEC is a right triangle. Because angle AEC, this angle equals to 90 degrees. Okay, so the orange triangle, triangle AEC is a right triangle because angle AEC equals to 90 degrees in its size. Therefore, again, we can implement the Pythagorean theorem in the orange right triangle, triangle AEC. And according to the Pythagorean theorem, the square of the hypotenuse, that is actually AC square, equals to the sum of the squares of the perpendiculars equals to AE square plus EC square. That is according to the Pythagorean theorem. Again, according to the Pythagorean theorem, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars equals to AE square plus EC square. But what is the value of AC? AC equals to 14 units. It is given us in the question, so AC square is 14 square, 14 square is 196, equals to AE square. AE equals to H, so AE square is H square, plus EC square. EC equals to A plus 8. Again, EC equals to A plus 8, so EC square is A plus 8 square. So in total we got question number 2 that states that 196 equals to 8 square plus A plus 8 square. But we have already found out that in question number 1 that 8 square equals to 64. 8 square equals to 64 minus A square. According to equation number 1, 8 square equals to 64 minus A square. So we can substitute 8 square in equation number 2 by 64 minus A square. Okay, so we'll do it now. So 196 will be equal to 8 square, that equals to 64 minus A square, plus A plus 8 square, that is actually equals to A square plus 64 plus 16A. So in total we got that 196 equals to 64 minus A square plus A square is 0, so A square is cancelled, plus 64 plus 16A. So here 64 plus 64 is 128, so I write it down. In total we got that 196 equals to 128 plus 16A. Sorry, okay, so 196 equals to 128 when plus 16a. Here we will subtract 128 from equation number 2, and we will get that 196 minus 128 is 68 equals to 16a. So here we will divide this equality by 16 in order to get the value of a, and we will get that a equals to 68 over 16. We got that a equals to 68 over 16. Here we will divide the numerator and the denominator by 4. 68 over 4 is 17, and 16 over 4 is 4. So in total we will get that a equals to 17 over 4. A equals to 17 over 4 units. A equals to 17 over 4 units. And we also have equation number 1 that states that h squared equals to 64 minus a squared. Equation number 1 states that h squared equals to 64 minus a squared. So here we will square this equality in order to get the value of a. A squared will be equal to 17 squared, that is 289, over 4 squared, that is 16. So a squared equals to 289 over 16. So we can substitute a squared in equation number 1 by 289 over 16, and we will get that h squared equals to 64 minus, instead of a squared we will write 289 over 16. So we got equation number 1. It states that h squared equals to 64 minus 289 over 16. Here we will multiply 64 by 16, and then we will divide it by 16 in order to have a common factor with this number. We will get that h squared equals to 64 times 16 is 1024 minus 289 over 16. So we got equation number 1 that states that h squared equals to 1024 minus 289 over 16. 1024 minus 281, 1024 minus 289 equals to 735. So I will write it down. So equals to 735 over 16. So we got equation number 1 that states that h squared equals to 735 over 16. So here we will take a root out of this equality in order to find out the value of h. So we get that edge equals to edge equals to the root of 735 over 16, and actually 735 equals to 15 times 7 times 7 over 16 is 4 times 4, and actually the root of 7 times 7 is 7 and the root of 4 times 4 is 4, so we can take out 7 over 4 out of the root. We get that edge equals to edge equals to 7 over 4 is taken out of the root. Inside the root what is left is only 15. So in total we got the value of edge equals to 7 over 4 times root 15 units, and we have already found out that A equals to 17 over 4 units. Again, the value of edge is 7 over 4 times root 15 units, and the value of A is 17 over 4 units. So now we know that the area of any triangle, the formula for the area of any triangle, A is the abbreviation for area. The area of any triangle equals to the base of the triangle times the height to the base over 2. You should remember that the height must create 90 degrees with the base, otherwise it is not the height. Okay? So the area of triangle ABC will be equal to the base of triangle ABC, that is actually BC, times the height. The height is AE, that equal to H, because the height AE creates 90 degrees with the base BC, because this angle is 90 degrees and this angle is 90 degrees. So the height creates 90 degrees with the base, so H is the height of triangle ABC, so it is the base BC times the height, that is H, over 2. Okay, so the area of triangle ABC is the base BC times the height, that is H, over 2. Okay, but we have already found out that the value of H is actually equals to 7 over 4 times root 15 units. So we can substitute H in this formula by 7 over 4 times root 15 units. So the area of triangle ABC will be equal to the base BC times the height, that is 7 over 4 times root 15 units, all divided by 2. Okay, so the area of triangle ABC equals to BC times 7 over 4 times root 15 over 2. But what is the value of BC? The value of BC equals to A plus 8. Again, the value of BC equals to A plus 8. That is actually 2A plus 8. Okay, so the area of triangle ABC equals to BC, that is equals to 2A plus 8 times 7 over 4 times root 15 over 2 Okay, so the area of triangle ABC equals to 2a plus 8 times 7 over 4 times root 15 over 2. But we have already found out that a equals to 17 over 4 units. So we can substitute a in this equality by 17 over 4 units, and 17 over 4 times 2 is 17 over 2. So we'll get that the area of triangle ABC will be equal to 17 over 2 plus 8 times 7 over 4 times root 15 over 2. So we got in total that the area of triangle ABC equals to 17 over 2 plus 8 times 7 over 4 times root 15 over 2. Okay, so here we have 17 over 2 plus 8, so here we will substitute 8 by 16 over 2 in order to have a common factor with this number. And we will get that the area of triangle ABC will be equal to 17 plus 16 over 2 times 7 over 4 times root 15 over 2. Okay, the area of triangle ABC equals to 17 plus 16 over 2 times 7 over 4 times root 15 over 2. 17 plus 16 is 33. So I'll write it down. The area of triangle ABC will be equal to 33 times 7, and 2 times 4 is 8 times root 15 over 2. Okay, we got that the area of triangle ABC equals to 33 times 7 times root 15 over 8 over 2. 33 times 7 is 221, and here we can move 2 to the denominator, and 2 times 8 is 16. So in total we will get that the area of triangle ABC equals to 33 times 7 is 231 times root 15, and here we have 2 times 8. Okay, so in total we got that the area of triangle ABC equals to 231 times root 15 times 200 times 2 times 8. 2 times 8 is 16, so write it down. So the final answer is that the area of triangle ABC equals to root 15 times 231 times 16 square units. Okay, so the final answer to the question is that the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, so we finished the first method to find out the area of triangle ABC. In the next step we will find the area of triangle ABC in a second way, in the second method. Okay. So, first of all, we will find the size of angle A by the equality that states that the sum of the angles in any triangle equals to 180 degrees. Therefore, angle A plus angle B plus angle C will be equal to 180 degrees. It is true in any triangle. So angle A plus angle B plus angle C must be equal to 180 degrees. Okay? This statement, equality states that the sum of the angles in our triangle ABC equals to 180 degrees. So angle A plus angle B equals to 2x, and angle C equals to x. So we got that angle A plus 2x plus x equals to 180 degrees. 2x plus x is 3x. So I write it down. We got that angle A plus 3x equals to 180 degrees. Angle A plus 3x equals to 180 degrees. Here we'll subtract 3x from this equality in order to get the value of A. We will get that the value of A equals to 180 degrees minus 3x. So angle A equals to 180 degrees minus 3x in its size. So we can write here that the size of angle A is equal to 180 degrees minus 3x. Okay? So in the next step, I will present to you a new formula to find the area of any triangle. That will be rule number 4, and we will calculate the area of our triangle according to the new formula. So rule number 4 is actually a new formula for the area of any triangle. Okay, so if we have triangle ABC, that can be any triangle, not necessarily our triangle, but any other triangle. And we know that the size of side AB of triangle ABC equals to A units, and the size of side AC of triangle ABC equals to B units, and the angle between side AB and side AC of triangle ABC is theta. Then, according to the new formula, the area of triangle ABC equals to A times B times sine theta over 2. Okay, so the area of triangle ABC equals to A times B times sine theta over 2. And it is true for any triangle, so we will use this formula in order to find out the area of our triangle ABC. Okay, so the area of our triangle ABC will be equal, A is the abbreviation for area, the area of triangle ABC will be equal to AB times AC times sine of 180 degrees minus 3x over 2. So according to the new formula, the area of our triangle ABC, will be equal to AB times AC times sine of 180 degrees minus 3x over 2. Okay, so what is the size of AB? The size of AB equals to 8 units. And what is the size of AC? AC equals to 14 units times sine of 180 degrees minus 3x over 2. So the area of triangle ABC equals to 8 times 14 times sine 180 degrees minus 3x over 2. Here 14 over 2 is 7, and 7 times 8 is 56, so I write it down. The area of triangle ABC, this is equation number 1, equals to 56 times sine of 180 degrees minus 3x over, that's all. We already found out that 14 over 2 is 7, and 7 times 8 is 56, so the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. We have trigonometric identity that states that sine of 180 degrees minus alpha equals to sine alpha. So according to this trigonometric identity, sine of 180 degrees minus 3x equals to sine 3x. So I write it down. So the area of triangle ABC equals to 56 times sine, instead of 180 degrees minus 3x, according to this trigonometric identity, sine 180 degrees minus 3x equals to sine 3x. So the area of triangle ABC equals to 56 times sine 3x. Okay, this is equation number 1. In the next step, I will present you a new rule, rule number 5, that is actually the law of sines, and we will use the law of sines in our triangle ABC. So rule number 5 is actually the law of sines. I must emphasize that the law of sines is valid in any triangle. You can use it in any triangle. So I write down that in any triangle, if we have any triangle ABC, that can be any triangle, not necessarily our triangle ABC, but any other triangle. And the size of side VC is A units. The size of side AC of triangle ABC is B units. And the size of side AB of triangle ABC is C units. According to the law of sines. Okay, according to the law of sines, A over sinus A over A over sine A equals to B over sine B equals to C over sine C. Okay, and capital A, capital B, and capital C are the sizes of the angles. Capital A is the size of this angle, capital B is the size of this angle, and capital C is the size of this angle. So according to the law of sines, A over sinus A equals to B over sinus B equals to C over sine B equals to C over sine C. A over sine A equals to B over sine B equals to C over sine C. Okay, so we actually can implement the law of sines in our triangle ABC according to the law of sines in our triangle AB over sine X equals to AC over sine 2X. Okay, so the implementation of the law of sines in our triangle ABC means that A over sine X equals to AC over sine 2X. Okay, but what is the value of AB? AB equals to 8 units, so it will be 8 over sine X equals to AC. AC equals to 14 units, so it is 14 over sine 2x. Okay, so 8 over sine x equals to 14 over sine 2x. And we have trigonometric identity for the value of sine 2x. According to the trigonometric identity, the value of sine 2x is equal to 2 sine x cosine x. Okay, so we actually can substitute sine 2x in this equality by 2 sine x cosine x according to this trigonometric identity. So we'll do it now. We get that 8 over sine x equals to 14 over, instead of sine 2x, we write down 2 sine x cosine x according to this trigonometric identity. So we got here this equality. So here we have sine x in the denominator of this side of the equality, and we have sine x in the denominator of the other side of the equality, and so we can cancel sine x. And 14 over 2 is 7, so in total we will get that 7 over cosine x equals to 8. So we got that 7 over cosine x equals to 8. Here we will multiply this equality by cosine x, and then we'll divide it by 8. We'll get that cosine x equals to 7 over 8. Okay, we found out the value of cosine x. Cosine x equals to 7 over 8. In the next step, I will present you a trigonometric identity, and from that trigonometric identity we will find out the value of sine x. The trigonometric identity states that sine square x plus cosine square x equals to 1. So from this trigonometric identity we will subtract cosine square x, and we will get that sine square x equals to 1 minus cosine square x. So here we will take a root out of this equality, and we will get that sine x equals to the root of 1 minus cosine square x. Okay, sine x equals to the root of 1 minus cosine square x. We know that cosine x equals to 7 over 8, so if we square this equality, we will get the value of cosine square x. We will get that cosine square x equals to 49 over 64. So cosine square x equals to 49 over 64. So here we'll subtract cosine square x by 49 over 64, and we'll get that sine x equals to the root of 1, and instead of cosine square x we write down 49 over 64. So we got that sine x equals to the root of 1 minus 49 over 64. Here we'll substitute 1 by 64 over 64 in order to have a common factor with this number. We'll get that sine x equals to the root of 64 minus 49 over 64. So here 64 minus 49 is 15, and the root of 64 is 8, so I will write it down. We will get that sine x equals to the root of 15, and the root of 64 is 8. So in total we got that sine x equals to the root of 15 over 8. Okay, now we will return to our first equation number 1. Equation number 1 states that the area of triangle ABC equals to 56 times sine of 3x. According to equation number 1, the area of triangle ABC equals to 56 times sine 3x. Here we have a trigonometric identity for the value of sine 3x. The value of sine 3x is actually equals to 3 sine x minus 4 sine cube x. So actually we can substitute sine 3x by this expression, because sine 3x equals to this expression, and we will get that the area of triangle ABC equals to 56, and sine x equals to 3 sine x minus 4 sine cube x. Okay, so the area of triangle ABC equals to 56 times 3 sine x minus 4 sine cube x. So here we will take sine x as a common factor of this equality. We will take out sine x as a common factor of this expression, and we will get that the area of triangle ABC equals to 56, and sine x is a common factor of this expression. So inside the brackets what is left is 3 minus 4 sine square x. Okay, The area of triangle ABC equals to 56 times sine x. In the brackets we have 3 minus 4 sine square x. We have already found out that sine x equals to root 15 over 8. So we will square this equality in order to get the value of sine square x. Sine square x will be equal to the root 15 times root 15 is 15, and 8 times 8 is, or 8 square is 64, so sine square x will be equal to 15 over 64. Okay, so now the only thing that is left to do is to substitute sine x in equation number 1 by root 15 over 8, and to substitute sine square x by 15 over 64. Okay, so we will do it now, and we will get that the area of triangle ABC will be equal to 56 times sine x equals to root 15 over 8, and in the brackets we have 3 minus 4 times sine square x equals to 15 over 64. So in total we got that the area of triangle ABC equals to 56 times root 15 over 8. In the brackets we have 3 minus 4 times 15 over 64. Here 56 over 8 is 7, and also here we will divide the numerator and the denominator by 4, so 4 will be cancelled here, and 64 over 4 is 16. So in total we will get that the area of triangle ABC equals to 56 over 8 is 7 times root 15. Here in the brackets we have 3 minus 15 over 16. So here we will substitute 3 by 48 over 16 in order to have common factor with this number. Okay, and we will get that the area of triangle ABC equals to root 15 times 7, and instead of 3 we will write down 84 over 16 minus 15. So in total we got that the area of triangle ABC equals to root 15 times 7. 48 minus 15 is 33 over 16. Okay, so the area of triangle ABC equals to root 15 times root 7 times 33 over 16. Okay, root 15 times 7, the area of triangle ABC equals to root 15 times 7 times 33 over 16. 7 times 33 is 231, so write it down. We will get that the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay. Okay, so the final answer to the question is that the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this triangle ABC. We know that side AB of triangle ABC equals to 8 units, side AC equals to 14 units, and angle ACB equals to x degrees in size, and angle ABC equals to 2x degrees in size. Okay, and we want to find out the area of triangle ABC. Okay, and in the first method, we made the construction. We draw line segment AD in such a way that angle ADB equals to 2x degrees in size, exactly like angle ABD that also equals to 2x degrees in size. So in triangle ABD we have two equal angles. Both of those two angles are equal to 2x degrees in size. Or in triangle ABD, angle ADB equals to angle ABD. Both of those two angles are equal to 2x degrees in their sizes. And we have a rule number 1, about triangle that has two angles that are equal to each other. According to rule number 1, in front of equal angles in the triangle there are equal sides. So actually, if we have triangle ABC that has two equal angles, those two angles are equal to each other, both of them are equal to alpha. So if we have triangle ABC with two equal angles, then according to rule number 1, in front of equal angles there are equal sides. So in front of this angle alpha we have side AC, and in front of this angle alpha we have side AB. So according to rule number 1, in front of equal angles there are equal sides. So those two sides that are located in front of those two equal angles are also equal to each other. That is to say, AB equals to AC. Again, in front of equal angles there are equal sides. So in front of those two angles we have side AB and side AC. So according to rule number 1, those two sides are also equal to each other. That is to say, AB equals to AC. Okay, so we actually can implement rule number 1 in our triangle ABD, because triangle ABD has two angles that are equal to each other. Both of those two angles are equal to 2x. So according to rule number 1, in front of those two equal angles there are equal sides. In front of this angle that equals to 2x we have side AD, and in front of this angle we have side AB. So according to rule number 1, those two sides are also equal between them. That is to say, AB equals to AD. Okay? Again, in triangle ABD we have two equal angles. Both of those two angles are equal to 2x. So in front of those two angles there are equal sides. That is to say, AB equals to AD, because AB and AD are located in front of those two angles that are equal between them. So those two sides are also equal to each other. That is to say, AB equals to AD. AB equals to AD according to rule number 1, but we know that AB equals to 8 units. It is given us in the question. AB equals to 8 units, so we can derive from this equality that AD also equals to 8 units. AD also equals to 8 units. Okay, and then I presented to you rule number 2 that talks about exterior angle and interior angles. In triangle ABC, angles alpha, beta, and gamma are defined as interior angles, and angle ABL is defined as exterior angle. And actually, angles alpha and beta are located in the opposite side in relation to angle gamma. So for that reason, they are defined as opposite interior angles. And then I presented to you rule number 2 that states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So according to rule number 2, the exterior angles ABL, this angle is equal to the sum of the two opposite interior angles. Angle ABL equals to angle alpha plus angle beta, because the exterior angle ABL is equal to the sum of the two interior angles, and angle alpha and beta are the opposite interior angles, so angle ABL, that is the exterior angle, is equal to the sum of the two interior angles, that is to say, it equals to alpha plus beta. So according to rule number 2, the exterior angle ABL equals to the sum of the two opposite interior angles. It equals to alpha plus beta. Okay, angle ABL equals to alpha plus beta according to rule number 2, and we again can implement rule number 2 in our drawing. We have triangle ADC. Triangle ADC has two opposite interior angles. Angle DAC is the opposite interior angle in triangle ADC, and also angle ACD is defined as opposite interior angle in triangle ADC, and this angle, angle ADB, is defined as exterior angle, and angle ADB equals to 2x, so angle 2x is defined as exterior angle. So according to rule number 2, the exterior angle that equals to 2x is also equals to the sum of the two opposite interior angles, or 2x equals to angle DAB plus angle ACD. Okay, according to rule number 2, the exterior angle that equals to 2x equals to the sum of angle DAC plus angle ACD. Those two angles are opposite interior angles, so the exterior angle that equals to 2x equals to the sum of those two angles, that is to say 2x equals to angle DAC plus angle ACD. Okay, but we know that angle ACD equals to x. It is given us in the question. Angle ACD equals to x, so we can substitute angle ACD by x, and we will get the equality that states that 2x equals to angle DAC plus x. From this equality we substituted x, and we got that angle DAC equals to x. This angle, angle DAC, equals to x. So actually in triangle ADC, this triangle ADC, we have two equal angles. So, and according to rule number 1, in front of equal angles there are equal sides. So in front of this angle we have side DC, and in front of this angle we have side AD. According to rule number 1, those two sides are also equal to each other. That is to say, DC equals to AD. Okay, according to rule number 1, triangle ADC that has two equal angles, according to rule number 1, in front of those two equal angles there are equal sides. That is to say, AD equals to DC. But we know that AD equals to 8 units. AD equals to 8 units. So from this equality we can derive that DC also equals to 8 units. Okay, DC also equals to 8 units. And then I presented to you rule number 3 that talks about isosceles triangle. First of all, if triangle ABC is an isosceles triangle, then AB equals to AC. Those two sides are equal to each other, and the base of this isosceles triangle is BC. Okay? So rule number 3 states that the height to the base in an isosceles triangle divides the base into two equal parts. According to rule number 3, the height, that is actually the red line, from point A, divides the base, that is BC, to two equal parts. That is to say, BD equals to DC. And the height also must create 90 degrees with the base, so this angle is 90 degrees, and this angle is also 90 degrees. So the height to the base BC divides the base BC to two equal parts. That is to say, BD equals to DC. According to rule number 3, and again we can implement rule number 3 in our triangle ABD that is in an isosceles triangle. Triangle ABD is in an isosceles triangle because AB equals to AD. Both of those two sides are equal to 8 units. Therefore, triangle ABD is an isosceles triangle. Therefore, according to rule number 3, if we draw a height to the base BD, then that height will divide the base BD to two equal parts. That is to say, BE equals to ED. According to rule number 3, the height VE divides the base BD to two equal parts. That is to say, BE equals to ED. Okay, and the height also creates 90 degrees with the base, so this angle is 90 degrees and this angle is 90 degrees. So BE equals to ED according to rule number 3. And if we define BE as A, that is to say BE equals to A, if BE equals to A, then from this equality we can derive that ED also equals to A. ED equals to A, so ED equals to A. Okay, so actually the green triangle is a right triangle because of the fact that angle AEB equals to 90 degrees. Therefore, we can implement the Pythagoras theorem in the right triangle, triangle ABE. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to BE square plus AE square. Okay, in the right triangle, triangle ABE, we implemented the Pythagoras theorem that states that the square of the hypotenuse, that is AB square, equals to the sum of the squares of the perpendiculars, equals to BE square plus AE square. So AB equals to 8, so AB square is 8 square, 8 square is 64, and BE equals to A, so BE square is A square, and AE equals to H, so AE square is H square. So in total we got that 64 equals to A square plus H square, and from equation number 1 we got that H square equals to 64 minus A square. And then related to the orange triangle, triangle AEC is a right triangle because angle AEC equals to 90 degrees. Therefore, we can implement the Pythagoras theorem in the right orange triangle AEC. According to the Pythagorean theorem, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. Again, according to the Pythagorean theorem, in the right orange triangle, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. But we know that AC equals to 14 units in size. So AC square is 14 squares, 14 square is 196. And uh, AE equals to H, so AE square is H square. H square, and EC equals to A plus H, so EC equals to A plus H, so EC square is A plus H square. A plus H square, so in total we got that 196 equals to H square plus A plus H square. But we have already found out in equation number 1 that H square equals to 64 minus H square, so we can substitute H square in equation number 2 by 64 minus H square. And we substituted H square by 64 minus H square, so we have here only one variable that is missing, that is A. So by solving this equality, we found out that the value of A equals to 17 over 4 units. And we have equation number 1 that states that H square equals to 64 minus A square. So if we square this equality, we will get the value of A square. A square equals to 289 over 16, so we can substitute A square in equation number 1 by 289 over 16. And after we substituted A square by 289 over 16, we got that the value of H is actually, the value of H equals to 7 over 4 times root 15, and we have already found out that A equals to 17 over 4 units. Okay, so the formula for the area of any triangle is the base of the triangle times the height over 2. Okay, so the area of our triangle will be equal to the base of the triangle, that is actually BC, times the height to the base, that is H over 2. The height is H because it creates 90 degrees with the base BC. This angle is 90 degrees and this angle is 90 degrees. So the height of triangle ABC is indeed the H. So it is the base that is BC times the height that is H over 2. We have already found out that H equals to 7 over 4 times root 15 units. So we can substitute H by 7 over 4 times root 15. And then BC equals to A plus 8. So BC equals to 2A plus 8. So we can substitute BC by 2A plus 8. And we have already found out that A equals to 17 over 4 units. So we will substitute A by 17 over 4 units, and we got that the area of triangle ABC equals to 15 times 200, or 15 times 231 over 16 square units. So that was the first way to find out the area of triangle ABC, and then we found out the area of triangle ABC in the second way, in the second method. In this method, we actually first of all found the size of angle A according to the equality that states that the sum of the angles in any triangle equals to 180 degrees. So angle A plus angle B plus angle C will be equal to 180 degrees. So from this equality, A plus B plus C equals to 180 degrees, we know that B equals to 2x degrees, C equals to x degrees. So we can substitute B by 2x and C by x, and we got that A equals to 180 degrees minus 3x. The size of angle A is 180 degrees minus 3x. Then I presented to you a new formula for the area of any triangle, that is actually rule number 4. According to rule number 4, the area of any triangle equals to A times B times sinus theta over 2. The area of any triangle equals to A times B times sinus theta over 2. Theta is the angle between side AB and side AC of the triangle. So we implemented this formula in order to find out the area of our triangle ABC. So according to the formula, the area of our triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x over 2. So that is the area of triangle ABC. It equals to AB times AC times sinus 180 degrees minus 3x over 2. But we know that AB equals to 8 units, AC equals to 14 units. So we can substitute AB by 8 and AC by 14, and we got that the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. And we have the trigonometric identity that states that the sine of 180 degrees minus alpha equals to sine alpha. So according to this equality, the area of triangle ABC equals to 56 times sine 3x. That is our first equation. And then I presented to you rule number 5, that is actually the law of sines that we can use in any triangle. According to the law of sines, A over sinus A equals to B over sinus B equals to C over sinus C, when capital A, capital B, and capital C are the sizes of angles A, B, and C. So we actually can use this formula, the law of sines, in our triangle ABC. So according to the law of sines, AB over sinus x equals to AC over sine 2x. Okay, AB over sine x equals to AC over sine 2x. But we know that AB equals to 8 units, AC equals to 14 units. Okay, we substituted AB by 8 and AC by 14. And we know that we have the trigonometric identity for sine 2x. Sine 2x equals to 2 sine x cosine x. So we can substitute sine x by this expression. So we got here this equality. From this equality we cancelled sine x because we have sine x in both sides of the equation. And we found out that cosine x equals to 7 over 8. Then we have trigonometric identity that states that sine square x plus cosine square x equals to x. From this trigonometric identity we got that sine x equals to the root of 1 minus cosine square x. We know that cosine x equals to 7 over 8, so if we square this equality we will get the value of cosine square x. Cosine square x equals to 49 over 64, so we can substitute cosine square x in this equality by 49 over 64. Okay, and we got that sine x equals to the root of 15 over 8. Then we return to our first equation that states that the area of triangle ABC equals to 56 times sine 3x. And we have the trigonometric identity that states that sine 3x equals to 3 sine x minus 4 sine cube x. So we can substitute sine 3x by this expression because this expression equals to sine 3x. So we substituted sine 3x by this expression and we got that the area of triangle ABC equals to 56 times 3 sine x minus 4 sine cube x. Then we took sine x as a common factor of this expression, and we got that the area of triangle ABC equals to 56 times sine x. In the brackets we have 3 minus 4 sine square x. We know that sine x equals to root 15 over 8, so if we square this equality we will get that sine square x equals to 15 over 64, and the only thing that is left is to substitute sine x by root 15 over 8 and to substitute sine square x by 15 over 64. Okay, and then we'll get the area of triangle ABC after we solve this equation, we found out that the area of triangle ABC equals to root 15 times 231 over 16 square units, exactly as we found in our first way. It is the same result as we got in the first way. In the first way we got exactly the same result that states that the area of triangle ABC equals to root 15 times 221 over 16 square units. So the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, thank you very much.